Welcome back. So this is the second video that I will be making on factors and multiples. In the last video, I dealt with definition of multiples and factors. I dealt with finding factors and multiples. I also dealt with prime and composite numbers. Now, we want to do the fourth objective, that is the fourth subtopic, which is prime factors and prime factorization. Let's go. Prime factors. So there is no special thing about this. So if you want to find the prime factors of a number, all you need to first do is to find the factors of that number. After getting all the factors of that number, then you select which ones are prime numbers among those factors. So let's see an example. So the question can say, find the prime factors of, so number one, let's say number one is 144 and number two is 120. So you can be asked to find all the prime factors of this. So it may be a smaller number and it may be a bigger number. So let's consider this first. Solution. So you remember the method that I taught in video 1 on how to find the factors of a number without missing anyone out. So you can go back to that video, so video 1, and see how I have done that. Very good. So you write 144, write it out, 144. Then you start breaking it down. So this 144 can be written as 1 times 144. So 2 can also work. I think 2 can work. 2 times what? That's 2 times 72, of course. So that will give me 144. What about 3? Yes, 3 can divide this. So that will be 3 times 48. That will be 3 times 48. Sorry, 3. This should be 3, not 2. 3 times 48 will also give me 144. So what about 4? Can 4 divide? This is the method that we use in video 1. Can 4 divide 144? So 4 can also work. 4 times 30. So that will be 33. Sorry? Remember 2. That will be 4 times 36. Very good. So can 5 work in this situation? 5 cannot work. So you try the next number after 5, that is 6. Can 6 work in this situation? Yes, 6 can work. That will be 6 times 24. So what about 7? 7 can never work here. Now what about 8? Okay, so 8 here will be, okay, 8 in 14, that will give me 1. So that will be remainder 6. So that will be 18. That will be 8 times 18. That will also work. So what about 9? Can 9 work in this situation? How many 9 can I get in 14? That's 1. 1 remainder 5. So it's 16. That will be 9 times 16. So 9 times 16 will also work. What about 10? 10 cannot work. What about 11? 11 cannot work. What about 12? 12 can work. That's 12 times 12. So 12 times 12 will also work to give us. Now, out of all of these factors, let's select which one. Okay, these are the factors of 144. If you take it from here to here. So on this table now, which ones are prime numbers among them? 1 is not a prime number. I have clarified that in the last video. 2 is a prime number, so I can write out the prime factors. Prime factors of 144 are equal to. So 1 is not, 2 is a prime factor, and 3 is also a prime factor. Is there any other one? Look down, then come to this side and look up. So that means only 2 and 3 are the prime factors of 144. It's as simple as that. They may give you big number like this, and they may give you small numbers. But you always try to follow the process and see what is happening. With this method now, you understand what we mean by factors. Everything, if you write out everything like this, so that means you have written out all of the factors of 144. But if you select 2 and 3 only, that means you have selected the prime factors among the factors. Very good. Now, the next is prime factorization. Let's learn about prime factorization. Prime factorization. Very good. So I will just rewrite this as prime factorization. So prime factorization means how can we write a number such that we will multiply the prime factors together to produce that number. So that means we want to write a number in terms of products. So how can we write that number such that we multiply its prime numbers or prime factors together to produce the number? So question under this topic or subtopic always come in this manner. They will say express the following as product of prime factors. So they can give the question like this, or they simply say find the prime factorization of the following numbers. So that's how question is asked under this subtopic. So when you see it, you should know what they are asking you to do. If questions say find the prime factors of the following, so no, that's what we did just now. But if they say find the prime factorization of the following number, that's what we just want to do. So for example now, number 1, let's say we have 120, and number 2 is 180. So I'm going to do this. So there are several methods that we can use to do prime factorization. So I will take it gently. So let's start with method 1. Method 1 for prime factorization. 120, I will draw my table, put 120 here. Then I will start using prime numbers to divide 120 repeatedly till I divided it up to 1. So that's the process. So let's start with the smallest prime number, which is 2. Because 2 can divide 120. If 2 cannot work, don't use it. But 2 can work. So 120 divided by 2, that will give me 60. Now, if 2 can still work, don't give up yet. You use 2 again. So 2 can work again. So 2 is 60, that will give me 30. Of course, 2 can still work again. Yes. So you keep using 2 till you can no longer use 2. So 2 in 30, that will give me 15. Now at this point, 2 can no longer work. So 2 can no longer work. So then we try the next prime number after 2. So that's 3. Can 3 divide 15? Of course, yes. So 3 in 15, that will give me 5. Yes. So I think 3 can only go once. So we have 5 now. So 5 is also a prime number. So we just bring 5 into the system. 5 in 5, that will give you 1. Once you get to 1 here, that's the end point using this method. So therefore, you will now write 120 equal to, multiply all these numbers together. So that will be 2 times 2 times 2 times 3 times 5. So that means 120 has been written as product of prime. So this is the final answer. But I purposely did this because question can go further and say in index form. Index form means you want to write it in terms of powers. So now 2 times 2 times 2 occurs 3 times. So I will just say this is 2 raised to power 3. So then times 3. How many 3 do we have here? Just 1. That will be 3 raised to times 3 raised to power 1. So then, how many times does 5 occur? That's once. That's 5 raised to power 1. You can decide not to put the 1. It's never a problem. But you can still decide to put it. It's still the same thing. But this is actually the answer. But if question further says in index form, you might not see the answer in option like this, maybe like this. So any of the two is correct. So very good. So let's see the second method. Yeah, before I go to the second method, if you have not subscribed to this channel, this is Study Made Simple Foundation. I am the tutor Sheikh Ridwanullah Abubakar. Please subscribe to our channel. Subscribe to the channel. If you are learning from the channel and you have not subscribed, that is not good. Help this channel to grow. Share it across. Share it to your group. Share it to your different educational group that you are, your class group. Invite your friends to like the channel, like the video, and subscribe. Subscription is free. You are not paying a dime. It's free. 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 So you are not paying anything to subscribe. Very good. So I'm going to leave the second one for you. Use this method and do the second one. So you will still get the same answer. Very good. Let's go to method 2. Method 2 on the same question. So number 2. All right. So I'm going to do this, the same 120 again. So how do we do this? I will use what we call factor tree method. Factor tree method. So all I need to do is to break this down into product of two numbers. Product of two numbers. So first, I can ensure that one of them is a prime number and the other one may not be prime number. So I can break it as 2 times 60. So 2 is a prime number, but 60 is not. So I can still break 60 again. 60 is the same thing as 2 times 30. Yes, 2 times 30. Now, 2 is still a prime number, but 30 is not. I can still break 30 as 2 times 15. So now 2 is a prime number, but 15 is not. Now I can still break 15 as 3 times 5. I think this is the highest we can go. Let me write it out very well. Let me write it out very well. So this will be 2 times 60. This will be 2 times 30. This will be 2 times 15. And this will be 3 times 15. 3 times 5. Now, so everything now here is a prime number. Now I will just circle on this table, on this tree, I will just circle the ones that are prime number. 2 is prime, but 60 is not. 2 is prime, but 30 is not. 2 is prime, but 15 is not. 3 is prime, and 5 is also prime. Then I will just multiply those ones together. That means 120 will be equal to 2 times 2 times 2 times 3 times 5. That's 2 times 2 times 2 times 3 times 5. So this is the answer. But in index form, I can still write it as 2 raised to the power of 3 times 3 raised to the power of 1 times 5 raised to the power of 1. So you can see that we have the same answer. No matter the method, you must get the same answer. Very good. We still have like one more method, or even this method that I just used. We can still use it in another way. So in case you are not getting it like this, you can still use it in another way. This same factor tree method, 120. So you can just choose any two numbers that will produce 120. Yes, you can choose any two numbers that will produce 120. So some people will say 12 times 10. 12 times 10. Of course, 12 times 10 will also produce 120. Now, notice that 12 and 10 are not prime numbers. So that means I can break 12 to 4 times 3. Yes, 12 can be broken to 4 times 3, and 10 can be broken to 2 times 5. So if you notice, you will see that I'm done with 10, because 10 is 2 times 5, 2 is prime, and 5 is also prime. But here, I am not done. 4 times 3, 4 is not prime, but 3 is prime. That means I can break this to 2 times 2 also. Good. Now, check everything that you have on the board. Circle all the ones that are prime. 2 is prime, 2 is also prime, 3 is prime, 2 is another prime, 5 is another prime. So 4, 12, 10, they are not prime, and 120 is also not prime. So now I will just write it out. 120 equal to, I will do 2 times 2 times 2 times 3 times 5. You can arrange it based on their size. That's 2 times 2 times 2 times 3 times 5. So this is the answer. Now in index form, I can still write it as 2 raised to the power of 3 times 3 raised to the power of 1 times 5 raised to the power of 1. So you can see that we still have the same answer. This is still on method 2, or if you like, call it method 3. Now, let's go for one last method on prime factorization. So I can clear this off. Let's go for one more method on prime factorization. So I will call it method 3. So this is method of successive, break multiplication. So now, if you look at this, 120, I can simply write it as 2 times 60. So if I like, or you select another pattern. So that means 2 is a prime number, but 60 is not. So I will just break 60 again. 60 can be broken as 2 times 30. So now you can see that I have 2 and 2, but 30 is still not. So repeat these 2 and 2, write them out. 2 times 2. But the 30, you still need to break the 30 as 2 times 15. Yes, you still need to break the 30 as 2 times 15. So 2 times 2 times 2 times 15. Very good. Next, I can have 2 times 2 times 2 times, now 15 is still not a prime number. You can break it as 3 times 5. So now, what we have here now, everything is prime. Everything is prime. So this is my answer. You can see that directly coming down like this, I got my answer. I got my answer directly like that. So, but in index form, I can still write it as 2 raised to the power of 3 times 3 raised to the power of 1 times 5 raised to the power of 1. So it's as simple as that. So you can see how simple prime factorization can be. So please, one more time, kindly subscribe to this channel, click the like button, comment, say good things about the video, and share it to your friends that also need this. So help the channel to grow. You shall also grow in all ramifications. Amen. Thank you.